Good evening, everyone. This is just an extra recording for talking about how to replicate using the replication of a call option to arrive at a binomial tree pricing formula. All right, we're not going to talk about this in exam. I wouldn't worry too much about for the exam purpose, given that our focus is on, as you will see on Wednesday, that we're going to use the riskless portfolio approach. So what this video is about is really just talking about here is an alternative approach that tries to replicate a long call option, and through doing so, we arrive at the same formula, right? So I didn't prepare a particular slide for this, right? But I will just talk about it using this video, right? Hopefully, some of you are gonna find this useful. Okay, I assume you have quite a solid understanding on using the riskless portfolio approach. So here, in this world, there are 3 securities and 2 future states, as we see over here, right? On the right-hand side, this is the previous slide I created for a different unit when I was visiting University of Otago. Let me just use the focus on the right-hand side, okay? And right, let me zoom out a little bit. Okay, so in this world, there are 3 securities and 2 future states. So here, what are the 3 securities? We have a share, which is the underlying asset of the call option. And the share price can go up or down. In this particular notation as what I have over here, which is U times E delta H times S, that just means in the up state, there may be dividend yield. So this particular stock may be paying dividend. So in the main approach that we have looked at in the lecture, we assume delta to be 0, or we implicitly assume delta to be 0. So this firm doesn't pay dividends. It goes up and down, right? Much like the same setting as we saw in the riskless portfolio approach. And this one, we have a second asset, which is the savings account. We call it a B for bank. Goes up or down, but given that it's a risk-free asset, it doesn't change the value. So it would just gonna be the value times by the e power to RH. H is the interval for the time. So we have assumed that H just being 1. I have the notation here just to cater for a general extension. And the last asset we have is the call option, where the call option value goes up or down. And what we're trying to find here, as you highlighted on the red bit over here, is that we're trying to price this call option, right? Having observed what the share price is gonna be in the next period, I mean, we don't observe it, but we assume we know that, right? And then because we assume we know the share price in the future, and given call option will expire at time 1, and that means we know what the value of the call option in the up state and the call option in the down state is, all right? So this is very important. So suppose we're trying to find out what C is priced the call option, and that's replicated. So here we're trying to replicate a call option, okay? So in the lecture, we have seen using a underlying share and a call option to replicate a riskless asset. And now we're trying to use the other 2 asset, which is share and savings, to replicate a call option, right? So to replicate it, that means at time 0, I have 2 portfolios. Portfolio 1 is buying delta shares and B amount of savings. We don't know what delta and B is at this stage. And portfolio 2 is that we're gonna be buying 1 call option. And we want to show that those 2 portfolios will have the same payoffs at the end. And if they have same payoffs at the end, they should cost the same. Otherwise, that creates an arbitrage opportunity. All right? And that's our goal, is to show that we can replicate using one and the other. So if we can show that at t equals to 1, portfolio 1 equals to portfolio 2, then according to theorem 1, which we haven't talked about it, but it just means that if they have the same payoff at one time period, they should have the same payoff at the other period, at the same cost at initially, all right? So what do we have at t equals to 1? At t equals to 1, given that we bought delta shares at the start, and we invested B amount of savings. So that means if in the up state, share price gone up, the call option value, which is the portfolio 2, should be equal to delta times the share price in the up state plus the amount that we have from the savings account. If the share price goes down, again, we should observe the same, that the call option value would go down. CD equals to delta multiplied by the share price in the bottom state plus the savings account. All right. So here, this is a classic example of two equations and two unknowns. So do we know what CU is? Yes, we do, because we know what share price is. CU equals to the maximum of ST minus K or 0, right? And we know what CD is as well, because CD equals to the maximum of ST minus K or 0, right? In this case, yet we know what both CU and CD is. And we know the share price in the up state, we know the share price in the down state, we know the interest rate, so that in these two equations, we have two unknowns, which are delta and B, right? Those two are the one that we're trying to find out, okay? And then here, I just I reproduce this, and so we have two equations, two unknowns. Really, the idea is just to solve it. It is the case that we're in these notations, it looks slightly more complicated than one we have in the lecture example, because we don't have delta H here. That really just represents the dividend yield coming from the stock. If the stock doesn't pay dividend, that just becomes e power to 0h, which becomes just 1, all right? So much the same, and if you want to bear with it, it just means that we need to solve it, right? So you can have equation 1 minus equation 2, that gives you CU minus CD, and you get rid of the B times ERH part, right? If equation 1 minus equation 2, that part is gone. So which means you can rearrange it to get delta equals to E power to minus delta H times CU minus CD divided by S times U minus D, right? And then once you find out what delta is, you can substitute it in and to work out what the B is, right? That's just the second unknown variable. And there are a number of different ways to do this. And if we trust the math over here, then B equals to the E power to minus RH times this, all right? And that looks familiar to what we have seen in the lecture note. And then the last thing here is that having worked out what delta and B is, you can just work out what the call option price is. Because remember, if CU equals to this, CD equals to this, that just means this portfolio 1, by buying delta shares and B amount of savings, it will give you the same value as the call option in the up state, as well as giving the same value of the call option in the down state. In that case, we replicate the call option value such that the call option price should be the same as the cost to construct portfolio 1. All right. So now we know what share price is at the start. And now we worked out what B is. We know what delta is. You just need to find out what C0, which is delta times S plus B, right? So that's what we're trying to have. C equals delta S plus B. And through some sort of the algebra, and we arrive at the same formula as the one that we saw in the lecture notes, except that we just don't have the delta here, right? Because this particular delta over here represents dividend yield, all right? So that gives you a different approach to arrive at the binomial option pricing formula. And the approach that we used and discussed in this video is replication of a call option, all right? I hope you enjoyed this video, and if you have any questions, as usual, just post the question on the discussion forum. All right, have a good night.